to 15 minutes. The limb of an instrument is divided into 15 minutes. Design a suitable vernier to read 20 seconds. We have to design a suitable vernier to read 20 seconds, right? The question is, a limb of an instrument is divided into 15 minutes. Design a suitable vernier to read 20 seconds. My least count, S by N. My least count, 20 seconds. What is my S? 15. I'll convert it into seconds. My N by calculations will be equal to how much? 45. Right? My N came equal to 45. Therefore, 44 divisions of the main scale will correspond to 45 divisions of the vernier scale. 45 divisions of the vernier scale will correspond to 44 divisions of the main scale to form a direct vernier for this instrument. Right? Let's do another question. I'm trying to solve as many questions as possible. Question is, construct a vernier to read 30 seconds. To be used with a scale graduated to 20 minutes. The question is, construct a vernier to read 30 seconds to be used with a scale graduated to 20 minutes. Least count is equal to S by N. What is my least count? 30 seconds. What is my S? Scale has been graduated to 20 minutes. My S is 20. I'll convert it into seconds, and by calculations, my N, that is the number of divisions in the vernier scale required, comes equivalent to how much? 40. Right? So 40 divisions of the vernier scale will correspond to 39 divisions of the main scale for a direct vernier. 40 divisions of the vernier scale will correspond to 39 divisions of the main scale to form a direct vernier for this case. Let's do another question. Question is, the arc of a sextant is divided to 10 minutes. The arc of a sextant is divided to 10 minutes. If 119 of these divisions are taken for the length of the vernier, into how many divisions must be vernier divided must be the vernier divided in order to read A 5 seconds and B 10 seconds. So the question is, the arc of a sextant is divided to 10 minutes if 119 of these divisions are taken for a length of the vernier. Into how many divisions must be the vernier divided in order to read 5 seconds and 10 seconds? Let's do part A first. My least count is S by N. What is my least count? 5 seconds. What is my S? The arc of a sextant is divided into 10 minutes. My S is 10, I'll convert it into seconds. And my N, by calculations, will come equivalent to 120. This will form a direct vernier. How? Because 120 divisions on the vernier scale correspond to 119 divisions are taken for the 120 divisions on the vernier scale. So we have 119 divisions on the main scale, and by calculations, to read 5 seconds, my N came equal to 120. So 120 divisions on the vernier scale correspond to 119 divisions on the vernier scale. That means it's a case of a direct vernier, because in direct vernier, n divisions on the vernier scale correspond to n minus 1 divisions of the main scale. This was my part A of the question. Let's do part B. What is the defined least count? 10 seconds. S is 10 minutes. We convert it into seconds. By calculations, my N will be equal to how much? 60. This forms an extended vernier. How? Because in an extended vernier, n divisions on the vernier scale correspond to 2n minus 1 divisions of the main scale. How much? 119. So this is an extended vernier. In which 60 divisions on the vernier scale correspond to 119 divisions on the. So in this case, we design a direct vernier, and in this case, an extended vernier was designed, right? Moving on. Let's do another question. Let's do another question. Okay. So the question is, n divisions of the main scale are equal to n plus 1 divisions of vernier scale if each division on main scale measures a units. Find the least count. So the question is, n divisions of the main scale are equal to n plus 1 divisions of the vernier scale. If each division on main scale measures A units, find the least count. All right, let's try to solve. What is my main scale division? MSD. If each division on main scale measures A units. Right? There is an alternate formula for least count where least count is equal to 1 MSD multiplied by 1 minus M by N, where M is number of divisions on main scale, N number of divisions on vernier scale, right? So I'll try to find the least count of this vernier scale by using this formula, right? So let's do it. My least count is equal to, what is my 1 MSD? A. What is my M? Right? What is my M? In divisions of main scale. N is the number of divisions on the main scale, and here in this case it says in divisions of main scale, means the number of divisions is N is equal to N plus 1 divisions on the vernier scale. So my M is capital N and my N is N plus 1. My least count by calculations comes equal to A by N plus 1. Right? So this was the question. In divisions of the scale equal to N plus 1 divisions of the vernier scale. If each division on main scale measures A units, find the least count. And we found the least count by using the formula 1 MSD multiplied by 1 minus M by N, where M is number of divisions of the main scale and N is number of divisions of the vernier scale. Right? Moving on. Let's try to solve another question. Right. My next question is, okay, determine the number of divisions determine the number of divisions required on the vernier scale if it's combined with the main scale of least count 0.5. The least count of combination required is 0.05 mm for the direct vernier. What is the question? Determine the number of divisions required on the vernier scale if it is combined with the main scale of least count 0.5 mm and the least count of the combination required is 0.05 mm for the direct vernier. As we know, least count is equal to what is my least count of the combination of the vernier and the main scale? 0.05 mm. What is my S? If it is combined with the main scale of least count 0.5 mm. My S is the least count of the main scale. This S is the smallest division on the main scale. So my least count or my S of the main scale is 0.5 mm. So how many divisions of the vernier do I require? 10. Determine the number of divisions required on the vernier scale. So 10 divisions on the vernier scale are required if they are desiring to have this least count for the combination of this direct vernier. Right? 10 divisions are required on the main scale. Right? Let's try to solve another question. Okay. Let's do another question. My next question is okay, let's take this question. 10 divisions of vernier scale are equal to 10 divisions of vernier scale are equal to 11 divisions on the main scale. Of each 0.1 mm. What is the least count of the vernier scale? So my question is 10 divisions of vernier scale are equal to 11 divisions of the main scale of each 0.1 mm. What is the least count of the vernier scale? Least count is S by N. What is S? 0.1 mm. What is N? 10. 10 divisions of vernier scale are equal to 11 divisions. So N is 10. And this count is equal to how much? 0.01. Least count came equal to 0.01. And students, you must note that this was the case of a retrograde vernier. Because 10 divisions on the vernier scale were equal to 11 divisions of the vernier scale. Because in retrograde vernier, there is no divisions on the vernier scale correspond to 1 divisions on the main scale. Let's do another question. We are trying to solve as many questions as possible. Okay. The next question is an angle measuring instrument an angle measuring instrument reading up to 1/6 of a degree. And the main scale is equipped with a vernier having main scale divisions divided into 20 parts. The correct least count for the instrument is okay. So the question is, an angle measuring instrument reading up to 1/6 of a degree on the main scale is equipped with the vernier having main scale divisions divided into 20 parts. The correct least count for the instrument is. Let's try to find the least count. It's equal to S by N. What is my S? Reading up to 1/6 of a degree on the main scale. What is 1/6 of a degree? 10 minutes. That means least count is equal to 10. I'll convert it into seconds divided by N. What is N? N is 20. It is equipped with a vernier having main scale divisions divided into 20 parts, right? So the number of divisions on the vernier scale are 20. So the least count for this instrument comes equivalent to 30 seconds. Right? My least count is equal to 30 seconds. All right, let's do another question. We're trying to solve as many questions as possible. All right. The next question is a vernier caliper. A vernier caliper has 1 mm mark on the main scale. It has 20 equal divisions on the vernier scale. Which matches with 16 main scale divisions. Which matches with 16 main scale divisions for this vernier caliper. The least count is so the question is, a vernier caliper has 1 mm mark on the main scale. It has 20 equal divisions on the vernier scale, which match with 16 main scale divisions for this vernier caliper. The least count is, least count as already told, is equal to 1 MSD into 1 minus m by n, where m is the number of divisions on the main scale and n is the number of divisions on the vernier scale. So my least count is, what is my 1 MSD? 1 mm, right? How many are the divisions on the main scale? 60. What about n? 20. So my least count by calculations is equal to how much? That means my least count is 0.2 mm. Right? My least count is 0.2 mm. Okay, let's do another question. Question is, a surveyor is using a vernier compass A surveyor is using the vernier compass to measure the bearing of the line. The reading shows how much? 75 degrees and 40 minutes. And the vernier scale reading corresponds to 6th division. If each division on the vernier scale represents 30 seconds, how much? 30 seconds. What is the total bearing of the line? So the question is, a surveyor is using a vernier compass to measure the bearing of a line. The main scale reading shows 75 degree 40 minutes and the vernier scale reading corresponds to 6th division. If each division on the vernier scale represents 30 seconds, what is the total bearing of the line? Total bearing of the line is equal to mean scale reading plus vernier scale reading multiplied by what? Value of each vernier division. Right? So my total bearing will be I must write it the coinciding division. Coinciding division. Right? Please don't confuse it yourself. It's coinciding division. What is my total bearing of the line? What is my mean scale reading? 75 degree, 40 seconds. Which is my coinciding division? 6 multiplied by what is the value of each vernier division? Right? How much? 75 degree 40 minutes. Let me write it here. 75 degree 40 minutes plus this is how much? This is 3 minutes. So it can read up to total bearing of the line is, I may write it again, it is 75 degrees, 43 minutes and 0 seconds. This is the total bearing of the hinge, 75 degrees, 43 minutes and 0 seconds. These were the questions regarding the vernier scales. With this, we conclude today's video lecture. I hope it was informative and thank you for watching.